In this section, we are going to learn exploratory data analysis that is related to central tendency measures. But first, what do we mean by central tendency measures? When we are exploring a variable, usually the variable contains many data points. Looking at these data points collectively, especially if they are large enough, will not give us any useful information about that variable. This is because our brain are not trained well to extract information from many scattered points. Finding a typical value that can fairly summarize the data in this variable would be very helpful. So, central tendency measures are a group of typical values that tells us where most values are located. The mean or the average, which is the topic of this lecture, is one of the famous central tendency measures. The mean or the average is the sum of all values divided by the number of values. The mean is a basic estimate of the location of the data. The symbol that is used for the mean of the sample data is x-bar, and the mathematical formula to calculate the mean is this formula. This formula is very simple. It is just a fancy way to represent the same simple definition of the mean that we have just described, which is the sum of all values divided by the number of values. This symbol here means the sum. So the numerator simply reads the sum of all x's. It is written here from the first value to the last value with the index n. The denominator n means the number of values. For example, if we are calculating the mean for 10 values, then n here equals 10. Now that we understood what the mean is, let's learn how to calculate the mean in Python. To do that, we need NumPy and Pandas libraries. So let's first import these two libraries like this. Let's now create our first dataset, which is a list with some integer numbers, like this list. We can calculate the mean for these elements by using a NumPy function called np.mean, like this. Notice that we used the name of the list as the argument for this function. The output of this function is a single number, which is the mean or the average of the numbers in this list, which is here 6. This value seemed to be a fair representation of this dataset. The mean value tells us that most data are around 6. The mean can simply be calculated and explained. So it looks like it is an excellent measure for tendency. However, in reality, that is not always the case. The mean suffers from a problem, which is that the mean is sensitive to extreme values or outliers. To explore this idea, let's consider this data, which is similar to the above data with one added value, an extreme value, which is 95. We call it extreme because it is far from the rest of the values. Let's calculate the mean for this new data like this. And the mean is now around 17. As you see, one extreme value caused the mean to be almost tripled. This is why it is important to look for extreme values or outliers in datasets, because they are going to affect our analysis. Now, how can we calculate the mean if our dataset is structured as a NumPy array? To explore this, let's first create a NumPy array consisting of 100 random numbers using the NumPy function np.random.rand like this. To calculate the mean for this array, we use the function mean like this. Now, how to calculate the mean for data structured as a Pandas data frame? Let's first read a data frame from a CSV file using a Pandas function called pd.readCSV like this. To calculate the mean for a specific column, we select the column using square brackets. Then we apply the function mean like this. So the mean for the income column is 48,000. This can be done for all numerical columns in this data frame. If you try to calculate the mean for a column that contains strings like gender or education, you will get an error message from Python. But what will happen if we apply the mean function directly to the data frame, like this example? Let's explore it by running the code. As you see in the output, the mean was calculated separately for all numerical columns in this data frame. We can do so if we are interested in the means for all columns. With this, we come to the end of this lecture. In the next lecture, we are going to discuss another type of mean, which is called weighted mean or weighted average. Thanks for watching and see you there.